up here to talk about it too. Now, if you remember, the love of geometry just overwhelms me. Our normal old school, don't write this, just look at it. Formula for area of a triangle, base times height over 2. We just did a truckload of these in geometry. They had their triangles, they had to draw in the height, they had 2 right angles, da-da-da-da-da. It took forever. Now, you have a little nicer, easier formula. So it says the area of any triangle is 1/2 the product of the lengths of the 2 sides times the sine of the included angle. So if you have that triangle, if you're a picture person, I'm not even going to get crazy and label like A, B, C and talk about which formula and all that stuff. I'm just going to kind of make some numbers up here. So I'm going to pick an angle measurement, because I'm standing here, I'm going to call this one, let's say 23 degrees.
Let's draw this.
Draw this one, draw the green. And let's say included angle. Now that's a geometry vocab flashback. Included angle means the angle's between the 2 sides. So I'm just going to make up 2 side measurements. Let's say this one's 8 and this one's 15. Okay, so 23 is in between the 8 and 15 included. Now I don't even have letters on here, so I'm not like, oh gosh, which formula is it? The first one, the second, or the third? All it is to do the area, it's 1/2 times the sides times 8 times 15 times the sine of the angle in between. That's a 23. I'm running out of room at the edge there. So that's all these area formulas are. So I don't get caught up on, oh, which one do I use, the first, second, and the third? Who cares? Okay, it's 1/2 times the sides times the sine of the included angle. That's all it is. We're going to deal with. All right, so take a look at this. And maybe you might need a throwback on what that little tick mark is there. Find the area of the triangle having the indicated angle and sides. All right, I'm a picture person as always. I hear you guys getting your calculators. I'm actually going to label this time since they gave us A, B, C. So A is 38 degrees, 45 minutes. There's a throwback to chapter 4. Little b, 67, and little c is 85. So I'm not going to stand up here and be like, ooh, which formula is it? I just know it's 1/2 times the sides, so times 85 times 67, you can have it switched of course, times the sine of our included angle. And all I'm going to do is literally type that right into my calculator, and I'm going to review with you where the degree, minute, second, all that good stuff is. Now, for the 1/2, I'm just going to do a 0.5. You can do 1 divided by 2 if you really wanted, times 85 times 67. You can hit a times sign. It's going to know. I'm just going to go ahead and do sine. Okay, 38 degrees. 38. Now, especially for those of you that just joined, maybe have forgotten this, where chapter 4, this degree, minute, second is, you have to get into your angle menu. So second apps. You can see degree is the first one there. 45 minutes. Second apps. You can see that's number 2. And just for the thrill of it, we don't have seconds on this one. I'll try not to launch into how much I hate Texas Instruments sometimes. Remember, seconds, why wouldn't you put it in there with the others? Seconds, you have to hit alpha plus to pull up seconds if they put the seconds on there. They didn't, so I'm not going to worry about it. All right, let's round. It doesn't say what to round to. I'm just going to go to the tenth. So I'm going to say 1,782.3. If you round to that, that's fine. And, you know, hey, I'm even going to be fancy and throw a label on, a generic label, units squared. That is as wild as the area problems are. And like I said, you will get the formulas for it. So don't feel like you have to have it memorized, although I think that's a pretty easy one to use. Last thing we're going to do, a few word problems. There are a couple of word problems when we get to your mini test, and it gives us a chance to practice law signs. So a pole tilts toward the sun at an 8-degree angle from vertical. Cast a 22-foot shadow. It's going to be great for me to draw. Angle of elevation from the tip of the shadow to the top of the pole is 43. Remember, angle of elevation looking up, so it's the bottom angle because you're looking up. How tall is the pole? Okay, so let's start with, we've got this pole tilted towards the sun. Here's my sun. Now, normally, don't draw this quite yet, our pole is normally nice and straight up and down. We usually have a nice right triangle. Don't draw this yet. And it talks, of course, about the 43-degree angle of elevation. Now, here's the thing. Boy, that is a very messy right angle symbol. Here's the thing. The triangle I'm gonna work on, I'm gonna draw in green because I'm gonna change one of the sides. So our normal pole, like I said, is usually we like it to be square, a nice 90-degree angle, straight up and down, but we have this tilt. It's tilting towards the sun 8 degrees. Now, I'm not gonna get a protractor out and measure it. I'm just gonna kind of Hail Mary a slight swing of 8 degrees here. Don't measure. So this green triangle is the one I'm gonna be working off of. So, careful on this angle measurement. It's not just 90, it's gonna be 98. So I'm just gonna label that guy's 98. Okay, other things we know here. The other thing I gotta put on here, cast a shadow. Now, think about this. If the sun's behind me and I'm standing here, where's my shadow? I see you guys pointing on the bottom. The bottom, it's on the ground. So we have our 22-foot shadow on the ground. And it wants to know how tall is the pole. Well, the pole was that dashed green side that I swung towards the sun. So of course, I'm going to label that X. Now, not a right triangle, no SOHCAHTOA, Pythagorean theorem, that good stuff, because we have 98, so I have to use law of sines. Now, as always, I want an angle and opposite side. The only side I have is 22. Can you find the angle across from it? We can, because all three add up to what? 180. So, in your calculators, what's 180 minus 98 minus 43? Punch that in for me, 39. So I'm just going to label that in here. So I'm going to do the sine of 39 over 22. Okay, and then we want to find the side with X on it. It's across from a 43-degree angle. So sine of 43 over X. And then just like yesterday, some of you don't even write anything else. You just go straight to your calculators. That's fine. I'm going to write some more, of course, little cross products. So I'm going to have this diagonal 22 sine of 43. X sine of 39. And I know, you know, we're going to divide off sine of 39. Again, you don't have to write all this nitpicky algebra. I know a lot of you guys can go straight to the calculator. Totally fine with me. All right, punch that in for me. I don't care what you round to, as always. I got fancy and went to the 10th. Punch that in. What do you got? 23.8, or if you round to 24, I don't care, whatever. And I'm just going to label, because we're a word problem, we're in feet. So I'm going to throw a feet on it. Got it. So I don't think that's too awful. Just remember, might be a little rusty. We cover this, I know in geometry, I don't know algebra 2. Angle of elevation, you're looking up. So it's that bottom angle. Angle of elevation is pretty common. All right, more drawing. Here we go. So the course of a boat race starts at point A, proceeds in the direction south 52 degrees. But okay, I'm going to stop reading. As soon as I see that southwest, I'm like, this is a throwback to chapter 4. We're talking about bearings. So I'm going to draw the compass rose, of course, north, south, west, east. And then I'm going to try to start marking out this boat race. North, south, west, east. All right, let's start with that so we got something going here. Now, the course of the boat race starts at point A. Well, anytime you draw anything on a graph, we start at the origin. It proceeds in the direction south, 52 degrees west. I'm not, again, going to get a protractor and measure, but I'm like, okay, oh, well, 52 degrees, I don't know, let's go with that. To point B, and so this is going to be 52 degrees. Keep on reading. Then in the direction, so we're at B, of southeast to C. Now, hang on. I'm a little like, oh God, where do I put C? Read this. C lies directly 8 kilometers south of A, directly below A. So I'm going to put C on the axis directly below A, and now I'm going to connect them. And of course, they told us this was 40 degrees. Okay, 8 kilometers. Getting everything labeled, looking good. All right, so see like that. Now, next question. Approximate the total distance of the race. Well, total distance. We're starting at A. I need all three sides, and we're going to add them up. So, do I care which side you find first? No, I sure don't. I'm just going to label one of them. Let's do C, little A. Let's, for the thrill, I have a feeling we might need that other angle. Let's find our missing angle. So you've got 40 and 52, you're 92. What's 180 minus 92? 88. Okay. So little law sign, sine of 40 over 8. Start with your angle on given side. I don't care if we find little a or little c first, who cares, whatever. So I'm gonna do A, I'm gonna go alphabetical. Sine of 52 over A. And again, I'm just gonna pull up the calculator just to show you. I mean, I generally don't write anything else than that. I just go straight to the calculator because I know I'm gonna have this diagonal, 8 times sine of 52, so let me punch that in. And then I know I have this diagonal, and I know to get A alone, I'm gonna have to get rid of sine 40. I'm gonna have to divide sine of 40 off. So I just do it. So A, everything's to the whole unit, I guess. Let's round to the whole. If you want to put 9.8, I really don't care. If I see everything's to the whole unit. If you want to go 9.8, get crazy and do it. Okay, well, let's find C then. So I'm going to keep my left side the same. C, of course, 88. And then over little c. So same thing. I'm going to pull up my calculator. Well, hang on. I'm going to do this diagonal first. 8 times sine of 88 in my calculator. 8 sine 88. And then I know this would be your second diagonal. To get C alone, we're going to have to get rid of sine 40. So I'm going to divide that off.
If we don't put degree signs in all of our work, are we going to get deducted?
Technically, you should, Haley, because what if it's radians, but there's nothing in radians in this chapter, so I would not. But if we had both in it, yes. Oh, let's go 12, I guess. All right, so total race. What's 12 plus 10 plus 8? Total race, what do you got? 30. And I'm just going to label, we're in kilometers. Got it. So not too bad of a problem. We'll throw back to our bearings from chapter 4. All right, last one, a geometry. A little geometry for you. Oh, I got to draw a circle though.
We don't have that.
Oh, good. I didn't make you do it. Sad. I had a note on here not to do it. That's sad.